So let's start with the first task, which was very easy. And the task was about some competition, and you needed to calculate the total time. So even though this task is very easy, I didn't see that everybody solved that, unfortunately. So what do we have? We have n, which is number of sets. Then we multiply this number by the number of minutes, yes? So it will be number of minutes times 60 plus number of seconds. Yes? So this is the time you spend practicing. And then you have duration of a break. So it is also in seconds. So if we have n sets, how many breaks will we have? N minus 1. So it is plus n minus 1 times p. Now you have the total. So next thing will be to display number of minutes and number of seconds, yes? So number of minutes will be t divided by 60. So it means integer division. And number of seconds will be simply t remainder of the division by 60. And that's all. So that's the whole task. Do you have any questions? So I would like to know who wrote, like, some people. For example, I will read the name in the stem. Abdurrahman with 3 N. So, Elkinaf Mohammed. So we know those who solved 6 problems. And let's go to problem number B. So in problem B, we have to switch between 2 channels. So we have starting channel, and we have finish channel, and we have different types of jumps. So you can jump by 1, or you can hold and jump, have a long jump. So let me ask you a question. If you found the solution to go from S to F when S is less than F, how can you solve to go from S to F when S is larger than F? So for example, you have a solution solved as F when S is less than F. How can you solve for situation when S is larger than F?
Switch and go back.
Of course, you just switch them. And this will solve the problem, yes? So if S is larger than F, then you can go like that. Because it doesn't matter, you have button plus and button minus. And if you replace all pressing of plus to minus, and vice versa, then you will get the same solution. So we need to solve only for one case, when S is less than F. So now let's see what we have. So let's say that this is the whole portion of numbers that we have. So the number of channels starts with 1 and ends with n. And we can skip, jump, k channels at once. Yes? So we can jump once, or we can jump k channels. So that's the whole idea. Now, what are the different solutions that we have? So we can start here, S, and want to go here, F. So what are the different solutions? We can jump k times before F and after F. So if we can jump to F directly, this is good. So no remainder, this is the best solution. Now, if we cannot jump to F directly, then we jump either before or after, and now consider how many simple hits of the button we need. Does it make sense? Okay. So that's ideal solution. But what can happen? It can happen that F can be near M and S can be near 1. So these are quite different solutions that we need to bear in mind. So let's say that F is near M. So if I want to go before F, it is easy. But if I want to go after M, this is the place I will go. But now it's not available. So where would I go? M. I will go to M. So I need to calculate what happens if after F, so this position plus K belongs after M. So it is larger than M. Then I can just go from N backwards. Yes? So this is modification. But there is also another modification. So if S is near 1, what we can do is we can jump backwards to 1. And then from 1, jump upwards. So it might help to reduce the number of simple present. So what is the simple present? +1 or -1. And the jump is K. So I want to go, for example, to, let's say, to 13, and it doesn't matter, so jumps K is equal to 5, so I want to go to 13 from 5. No. Let's say, from where it will be easier. So plus 5, let's say 16 from 2. So S is 2. So if I jump using 5, what will I get? 17. Yes? And then 1 back. Everything is okay. Now S is 3. So if I jump straight, it will be 13. After that, plus 5. 18. So to go to 16, I will need how many? 2 more. Yes? But if I jump backwards, I will go to 1, and then from 1, in just 3 jumps, I will reach 16.
May I take some shoes from Rachel?
So, if instead of going just straight forward, you jump backwards, you can do that. So the same works if F is near M. The same that we're talking about. So you need to take this into account. That if F, if this point is less than K plus 1, or F point M minus F is less than K. So then you have a special solution that you need to take into account. And then when you gather these whole things, because what can happen, both S and F might be near the ends, to the opposite ends. So you will need to take into account both of them. And that's all. So do you have any questions on that? Who solved B? Okay. Is it different from your solution?
It's the same, but yeah. I didn't consider both two cases.
Yeah, I think you considered them when you calculated the value here and then calculated the value here, then it was added to that. Yeah. So it's just you work separately on S and then separately on F and then combine the values. So you have 2 values from S, 2 values from F, and then you try to add them together, and that's all. You find the median value. So you have 4 options. Usually it's like that, 4 options, and then you just decide which one is better. So this is question B. Does anybody have any questions on the programming language. So it's just a series of some if, yes? And you need to create a separate function to do this. So you don't care about whether s is less than f or s is greater than f. You just create a separate function that does it, that solves for this occasion. And then you have one simple if. If it is less than, then we call it like that. If it is greater than, we call it like that, and that's all. And the solution will be the same. So it will save you a lot of time. Okay. No more questions? Let's go to task C. So task C, it is triangulation method. Does anybody know what is triangulation? So imagine you have a cell phone. So we want to find you using the cell phone. So when you are connected to your service provider, it is not like you connected to only one tower. Your phone tries all the towers it can reach and then selects one that has the best connection. And it repeats the process after some time because you can move, so it might reconnect to another tower. So if service provider wants to find your position, it will ask those towers that can reach your phone to send you a signal and receive the signal back. And they will measure the delay. So the delay is proportional to the distance from the tower to the cell phone. So triangulation means we have 3 towers, 1, 2, and 3. Now we measure the distance to first tower. We measure the distance to the second tower. And now we measure the distance to the third tower. And they will intersect in only one point. So that's how we exactly know where you are located. We need 3 towers. Do we have here 3 towers? No. He measured the distance in 2 places. So how many solutions will we have? Look, how many intersections of these 2 solutions? So we will have one solution here and one solution above. And that's why we talk here that the coordinate must be negative. You've seen that. Why? Because you have 2 solutions to this problem. So now let's create what we have. Let's write the equations. So we have a point with coordinates x and y. This is the treasure we're looking for. So now we know that x and y, this point, is located at the distance r1 from 0. So it satisfies x squared plus y squared equals r1 squared, which is equation of the circle. Yes. Now r2 is the distance from point A0. So you will have x minus a squared plus y squared equals r2 squared. So you have this system of 2 equations. Yes. And you need to solve them. So what we do? Because y has 2 solutions, we don't care about y. We care about x. X has only one solution. So what we do is we subtract them. So what will we have? X squared minus x minus a squared, r1 squared minus r2 squared. So we can simplify this. This is the difference of 2 squares. It will be x minus x plus a, x plus x minus a equals this difference. And now x minus x is nothing. So we will have 2x minus a equals r1 squared r2 squared divided by a. This is a. And now you have x, which is r1 minus r2 squared divided by 2a plus a over 2. And this is the formula for x. Now how to find y? Just use this equation and find y. So that's all. Yes? So it's just analytical geometry. You construct equations, you solve the equations, you find the coordinates of that point. Any questions?
Why can't we use the formula of Piron, like finding the area of triangle and then its height, and from
Sure.
but it says that in the test 4 or test 5 it's a mistake.
It's a precision mistake.
So we need to use long after long.
Double. Not integer. So as you see, everything will be floating numbers, real numbers. So you create everything double, and then you print double. So you need double precision. That's the whole point. Because when you use Heron's formula, you take square root here. This will not have precision problem. This is not a precision problem. Y will be the precision problem. Because then you take a square root, and square root will have a problem with precision. So if you create everything double, it should work. So it doesn't matter whether you use Heron's formula or this formula. I'm just explaining you one idea because here everything is nice. But if I change and I put him like on the hill, change his height, then the distances, this A will not be equal to the side of the third side of the triangle. So now you have a problem and you don't know how to solve it. You might use Pythagorean theorem or something like that. But here, no, not a problem. We just create. Sometimes for geometry, it is very useful to use analytical representation, and that's all through it. That's just the whole problem. Okay. Other questions? So, you know what's interesting? This was the easiest task I did. Because I practiced to solve all these tasks, and this was the easiest one. So I decided, oh, let's put the easiest task. And I was surprised that nobody solved this task. Okay. And also one person tried to solve this task and had exceeding memory. I was like, how is it possible to exceed memory if you just need like 4 or 5 variables? How do you exceed the memory? Like 5 variables. So you created the, oh no. So let's solve this problem easily. So the problem uses modular arithmetic. So you have 3 kinds of files, yes? 1, 2, and 3. 3 types. So type 1 goes directly cleaned, yes? Where is this? Science the first, okay. This, yes. Immediately, yes. 2 goes no, yes? 2 goes immediately no. And then 3rd goes back. And that's all, yeah? So now, you are asked, what happens to your exact number, the claimed number like that, 3 or 5, whichever. So first what you do is you find, so this is like a claim, remainder divided by 3. So if the remainder divided by 3 is equal to 1, then you say immediately yes. Now you might be asked, what is the number? Yes, what is the index? Here you should answer also which one you answer. Yes, number, the step number. Yeah. So the step number will be just the claim itself. If it is 1, then the claim itself is the answer, because you will go to the claim in this order. So this one, so if 1, yes, print out claim. So this will go to output. Everything nice, yes? If 2, same, no, and claim. So the only difference is with 3. Yes? So 3, case 3. So what we do in case 3? Okay, we have put this to the end. So what will be the number of it? So we need to read all n before we continue. Yes?
N divided by 3.
No, not exactly, but we will use it. So let's say we have n. So first thing, we need to have some iteration. We need to say some variable, which will be a variable, like int previous. So initially 0. And now when we print this claim, we don't print the claim, we print previous plus claim, previous plus claim. And the whole thing becomes while. Some cycle while n is greater than 0. And now we look into the case 3. Okay. So we skipped how many triples we have in n? Full triples. All full triples we skip. So we will write prev will be equal to prev plus n divided by 3 multiplied by 3. So all full triples. Yes. Then we have the rest, which is claim will become. What is the claim now? So it will be n plus what? So claim divided by 3. Yes? But not just n. Remainder of n divided by 3. Because we don't care about the rest. So if we have 5 files, 1, 2, 3, 4, 5. So this is the full triple. Yes? What is the remainder? 2. So this third will go here and it will be number 3. The remainder was 2. 3 divided by 3 is 1. 2 plus 1, it is now number 3. And now we need to change n. So now the number of numbers is different. Yes? So it is n remainder divided by 3 plus all triples. Full triples. How many full triples we have? Because all of them send the third number to the back. So it is n divided by 3. And that's all. So you go through this whole loop while n is larger than 0, and once it finishes, you have the answer. Prev stores how many steps you went through till this time. So it is just, so here, this is 3. and then 3 more. So while I operate over this, I don't remember that I skipped 3 of those. I need to remember that I went through 3 steps. So pref is just stores how many steps I went through. So how many times I divided by 3. It just remembers how many times I divided by 3. That's all. To answer this thing, because we need to answer the thing. If we didn't need to answer that, we didn't need to store prefix. But here we were asked to do this, so we do this. Okay. Any questions? So, as you see, the solution is very short. And no data required, yes? No like allocation of huge numbers are required. So that's the whole thing. You just go through the while, and you might ask, maybe it is not fast algorithm. What is the speed of this algorithm? What is the time complexity of this algorithm? Actually, it's just log n. Because every time you just divide. And divide by 3, so it's log 3n. So this is the complexity of the algorithm. So it will work, regardless of the number. So here they wrote 5 times 10 to the power 5. Nothing. You let them put 10 to the power 9. It will work anyway. It doesn't matter, because the complexity is logarithmic. Very quick algorithm. Because every time you divide by 3, n changes. You see, every time you divide by 3, so n decreases very fast. Questions? No. So now let's ask somebody to explain number b, so e, so I can press it. Who solved e? Let's listen to you.
I just use the bulletin function.
What?
Bulletin function.
Explain.
It's not so explain.
No, I mean, let's see. So you need to practice that. I'm not the one who will be running the whole explanation. I want others to know how to explain that, because in the future the club will work on this level. So I will only explain some tasks that were not solved by anybody. There's nobody who knows how to solve it. But looking forward, I want you to experience how to do this yourself. So, beware evil numbers. So evil numbers are numbers with some property, and we need to calculate what is the number of such.
It's like built-in function that returns true if number of ones in integer, like binary type, odd. So I check it if it's 0. I added 1 to counter. So
did you go through all the numbers from?
no, I go only n over 2.
Yeah, but through all the numbers.
So all the numbers.
Oh, okay.
But passive, I also wonder.
Yeah,
Nice
I thought you were using like easier solution. Okay,
Yeah.
that's
I
the
also
difference.
surprised.
That's the difference. So, all these very evil numbers, they finish with 0. They end with 0. So, because they all end with 0, we can just skip the 0. That's why we divided by 2. Yes? So this is division by 2 means you just don't look at the last digit, because it must be 0. You already know the answer. So now, after that, you have a number, and let's say this number is 1 and all zeros. Yes? So you want an answer of how many even numbers are below that, less than that. So all even numbers have even number of ones. Is it? Yeah. So I want to place here 2 ones, 4 ones, 6 ones, etc. How many ways I can do this? So here I have, let's say I have m digits. And I want to place 2 ones. I can do this m2 ways. So how many ways I can place 4? M4. Next, M6, etc. Yes? So what is the total number? Yes? What is the sum? Do you know what it means? So, is there anybody who doesn't know what this means? Okay, so n over k is binomial coefficient. Okay, so now you know. So, what is the sum of all of these numbers? n minus 1. Yes, n minus 1. So it will be 2 to the power of m minus 1, n minus 1. Because we don't count zeros, yes? Or maybe we count. No, we cannot count. So everything less than that will become like this number. So only zeros cannot be even number. Even number has to have ones, yes? So because of that, this is the answer for this problem. So once we calculate for that, we need to calculate for the remaining parts. Yes? So if we are given more complicated value, like 1, 0, 1, 0, 0, 0, so what we do, so we need to calculate all the numbers below that. Yes? So it will have 1, 0, 0, and then something. So we will calculate for that, but here, we don't calculate only even numbers, we will calculate odd numbers. So here we'll calculate L over 1, L over 3, etc. So this value is different. What is the sum? Two to the power of L. Because here we don't disregard any value. Any odd number of digits can work. So L minus 1. So the same as here. M minus 1 here, L minus 1. So this is the solution. And it works logarithmic. Yes? In logarithmic time. Because you just go from the largest digit downwards and calculate just one formula and add the values. And that's all. I'm surprised that your brute force worked. I thought 10 to the power of 9 will not work with brute force.
I also check triple times. I also check triple times what email that I could accept.
Yeah. That's interesting. Next, 3 kings is very easy problem, I think, yes. So 3 kings, maybe not everybody looked into the problem, but it was very easy problem. So you had to multiply A by X, B by Y, and C by Z, and list all the maximum numbers. So you need to find the maximum number and write the names corresponding to this maximum number. So if this maximum number is unique, you write only one name. If it is appears twice, you write 2 names, 3 times, 3 names. So that was very easy. You just needed to calculate multiplication and compare them and find the maximum number, and then go through all 3 of them and find. So what was the catch? What was the catch here? The space between them. So the only catch was when you put the space. So if you, for example, put name and then space, I don't know, I didn't check for that, but it might not work. It works? Oh, then. Usually, our testing systems were like very picky, and they even looked for the last symbol. If it is space, no, it's but if it takes, yeah, no problem. Okay, questions? No, it's easy. Next, for kettlebells. So for kettlebells is when you have P1, P2, P3, P4, and you want to divide them into two sums when you have equal sum, which is very simple. It's just set partition task, but with number 4, and can be solved very easily. You don't even need to come up with something crazy. What you do is, I mean, not just brute force. You need some, how to say? You need to think about one simplification. So if you want to put them on different scales, you need to think, oh, so regardless of how I put them, I will put somewhere P1. Yes? So when you do this, you say, okay, I will put P1 here. Then the solution is quite simple. So you now need to place P2, P3, and P4. And that's all. So you go over only those substitutions. So P2 and P3, P4, P3, P2, P4, P4, P2, P3, and then when here you have 2, so you have P2, P3, P4, P2, P4, P3, P3, P4, P2, and also when you have only one P1, so it will be nothing, P2, P3, P4. So these are the only options you have. You just need to go over all of these options and decide. But there are like more clever algorithms. So it is set partitioning, and for set partitioning we always do what? We sum all the numbers and divide by 2. So if you get a sum as odd number, is it possible to place them? So you immediately say no. And only if it is even, then you divide by 2, and then you want to find to P1 a subset of numbers that sum up to this half of the sum. So that's the whole idea. And you can create more like...
we just use maximum and minimum numbers. And maximum and minimum numbers is equal to middle numbers.
Oh, if you sort them. If you sort them, it might not work. It might happen that maximum number is equal to sum of 3 remaining numbers. So maximum number can be equal to 3 other numbers. So it's not just maximum plus minimum, but different ways. Yeah. If you sort, you can simplify the task. But still, this task is NP complete. So if you have set partitioning for thousands of numbers, it's already very complicated. It's not very easy task. So it is NP complete. So it means the solution is sub-exponential. So it will be 2 to the power of 1,000 divided by something, which is a great number.
Can you explain as you said here?
So you placed P1, and now you can put it solo and place all 3 other weights onto the second one. And you compare whether these sums are equal. Now, if it is not like that, then P1 plus P2 is equal to P3 plus P4. Or P1 plus P3 is equal to P2 plus P4, etc. So you just check all of them, and if any of them clicks yes, you print yes. Otherwise, you print no. Next, triangles. Oh, beautiful task. And the last task for today. So let's take a look at triangles with more levels. So let's say that we divide it by 1, 2, 3, 4, 5. So I will have, no, not like this, sorry. 1, 2, 3, 4, 5. And have 1, 2, 3, 4, 5. So this is the picture for more levels. Yeah. Now, how can we calculate the? So we have two types of triangles. One type of triangle points with one vertex up, and another type of triangles points with its vertex down. That's all. So we have this triangle that points up, and we have, let's say, this triangle that points down. So we have triangle pointing down, pointing up. So we need to calculate them separately, and that's all the solution. So how do we calculate the number of triangles pointing up? It is the number of vertices where we can start. So we will divide them into the triangles of different height. So we will go height, will go from 1 to n, where n is the total number. And now we will count how many ways are there to place the first point. So this top point. So here it will be 1, next will be 2, next will be 3, plus etc. So of height h, where will we end? So for example, for height 2 will end here. And we'll have 1, 2, 3, 4. Yes? What is the total number? It is n minus h plus 1. And you don't need to go through the loop to calculate this sum. This sum can be calculated as n minus h times n minus h plus 1 over 2. So you just do this loop for these numbers, and I can also tell you that you can even skip the loop, because if you open all the brackets, all the parentheses, and you simplify, there are formulas to sum squares, there are formulas to sum units, and just the constants. So you just combine them together, and you have one formula to calculate all the triangles that point upwards. But then you have a problem of all the triangles pointing downwards. Because here of height 2. So how many we have on this level? 1 and 2. Only 2 triangles here. Yes? And then here I have only one triangle of height 2. And that's all. So there are only 3 triangles of such kind. They are also going in these numbers. So 1 plus 2 plus 3 going upwards. But you need to end at a certain point. So where do we end? Where do we start? So of height 2, we start at this level where we have height 2 like this. Okay? So it will be n minus 2 already. And then we will finish at which level? This is 2, and we will finish at n minus 2 as well. So because we cannot go to this level, and this level, this is the final level. So we can go from this level to this level. And then we calculate the sum of these numbers. And that's all. So you just need to calculate the formula and sum all results of all formulas. And it will be the answer for the problem. Question? So if we have m levels, it means we have how many points? 1, 2, 3, 4, 5, 6, n plus 1 points. So we need to remember that the number of points is greater than the number of levels by 1. Very beautiful task on combinatorics. If we don't have any questions, we can finish on that.